In this work, we identify conflict, a previously unidentified issue that can arise in applications of Stackelberg games to interactive decision-making problems, which can result in suboptimal behavior. We present a method for measuring the potential for conflict in a given game matrix. We propose a novel reward definition that accounts for the altruistic tendencies of players and minimizes the potential for conflict. Using data gathered from experiments involving human drivers in simulated environments, we demonstrate that our proposed reward can approximate human decision-making in common interactive driving scenarios. An interaction between two players can be modeled as a Stackelberg game, where each player has a known set of possible actions and a known role as either leader or follower. Under these assumptions, a unique equilibrium can be computed. If the players have different assumptions about the identity of the leader or follower, this can result in them computing distinct equilibria to the game. In our first example, the players will compute the same equilibrium, regardless of who is leader or follower. Therefore, this game has no conflict. In our second example, if the row player believes they are the leader, they will compute a different equilibrium than in the case when the column player is the leader. Thus, if these roles are not established in advance, the players will not be able to interact effectively. We say that a game matrix with this property has conflict. We propose a normalized measure, area of conflict, that calculates the expected incidence of conflict over the parameter space of each player's reward function. A game matrix that is conflict-free has an area of conflict of 0, while a value of 1 indicates that conflict arises for all parameter values. Driving is an instance where players must interact and coordinate behavior, but have to make assumptions about the leader and follower roles. In a lane change scenario, whether the lane changing vehicle attempts to merge ahead or behind the lane keeping vehicle depends on the lane changing driver's assumption about their roles. Similarly, whether or not the lane keeping vehicle will yield for the lane merging vehicle depends on the lane keeping driver's assumption that they are the follower. In order to demonstrate the impact conflict can have on players' abilities to achieve their objectives, we measured how efficiently the vehicles completed objectives resulting from equilibria for games with and without conflict, while staggering the vehicle's initial positions. Our results show that conflict consistently affects the time taken for players to complete their objectives. This standard game formulation neglects the altruistic tendencies often demonstrated by human drivers when they interact. In these cases, when drivers interact, they are partially motivated by the other driver's reward function. Methods previously proposed in the literature, such as pure altruism or social value orientation, account for this by defining the rewards for each player as weighted sums of the naive rewards. In our example, if either driver is sufficiently altruistic, they will independently compute the same equilibrium to the decision-making problem, allowing for the efficient completion of the maneuver, irrespective of who takes the role of leader or follower, thus resolving the conflict. However, if both agents are too altruistic or too selfish, conflict still occurs. We propose an alternative formulation for altruism that matches the performance achieved by previous methods in the literature. We call these models egoistic, as they only consider the player's own altruistic tendency. This results in orthogonal regions of conflict in the parameter space. As an alternative, we propose a non-egoistic form of altruism that accounts for both players' altruism values, which we call augmented altruism. This results in a lower area of conflict for our lane change example. Our analysis shows that this variation of altruism consistently results in a lower area of conflict value for a range of game matrix values. In order to evaluate how well our proposed models can approximate human behavior, we gathered data from human subjects controlling a simulated vehicle in interactive lane change scenarios. In our experiments, we varied the role played by the participant and their awareness about the altruistic tendency of the other vehicle. Our results show that when the player is only aware of their own altruistic tendency, our egoistic altruism model captures the distinct modes of behavior demonstrated by the players. We also show that when the player has information about the other vehicle's altruistic tendency, our augmented altruism model approximates human decision-making better than egoistic models. In conclusion, altruism is an effective means for addressing conflict, a previously undocumented issue that can arise in interactive decision-making scenarios that can compromise the ability to interact effectively. We introduce a novel definition of altruism that minimizes the expected incidence of conflict in various interactive scenarios. We provide empirical evidence that our proposed model accurately estimates human decision-making in interactive driving scenarios.